this video we will see about heat exchangers. A heat exchanger may be defined as an equipment which transfers the energy from a hot fluid to a cold fluid with maximum rate and minimum investment and running costs. In heat exchangers, the temperature of each fluid changes as it passes through the exchangers, and hence the temperature of the dividing wall between the fluids also changes along with the length of the exchanger. Examples of heat exchangers: intercoolers and preheaters, condensers and boilers in steam plant, condensers and evaporators in refrigerator, automobile radiators, oil coolers of heat engine. So this is your types. Heat exchanger is classified into four major groups: nature of heat exchanging process, relative direction of fluid motion, design and constructional feature, and physical state of fluid. Here direct contact or open heat exchanger, indirect contact heat exchanger, that is regenerator and recuperator or surface exchanger. Relative direction of fluid motion, parallel flow or unidirectional flow, counter flow and cross flow. Design type: concentric tubes, shell and tubes, multiple shell and tube process, compact heat exchanger. Here it is parallel flow or unidirectional flow, condensers and evaporators. First type: nature of heat exchange process. Heat exchangers on the basis of nature of heat exchange process are classified as follows: direct contact or open heat exchangers, indirect contact heat exchangers. Direct contact heat exchangers. In a direct contact or open heat exchanger, the exchange of heat takes place by direct mixing of hot and cold fluids, and transfer of heat and mass takes place simultaneously. The use of such units is made under conditions where mixing of two fluids is either harmless or desirable. Example: cooling towers, jet condensers, direct contact feed heaters. Indirect contact heat exchangers. In this type of heat exchanger, the heat transfer between the two fluids can be carried out by transmission through wall which separates the two fluids. This type includes the following. First one is regenerators, second one is recuperators. See, you are allowing the hot water and cold water, so we can able to exchange the heat through the fluid passing through it. This is your container and this is your steam. Outlet will give you the non-condensable gas. Regenerators. In regenerator type of heat exchanger, the hot and cold fluids pass alternately through a space containing solid particles within bracket. These particles providing alternately a sink and a source of heat flow. Example: IC engines and gas turbines, open hearth and glass melting furnaces, air heaters of blast furnaces. Recuperators. Recuperator is the most important type of heat exchanger in which the flowing fluids exchanging heat are on either side of dividing wall. Within bracket you will be having the meaning of it in the form of pipes or tubes generally. These heat exchangers are used when two fluids can be or cannot be allowed to mix. Example: when the mixing is undesirable. Example, automobile radiators, oil coolers and intercoolers. Relative direction or fluid motion. According to the relative direction of two fluid streams, the heat exchangers are classified into the following three categories: parallel flow or unidirection flow heat exchanger, counter flow heat exchanger, cross flow heat exchanger. Parallel flow heat exchanger. In parallel flow heat exchanger, as the name suggests, the two fluid streams travel in a same direction. So within bracket we are giving the meaning for two kind of fluids, hot fluid and cold fluid. The two streams enter at one end and leave at the other end. Since this type of heat exchanger needs a large area of heat transfer, therefore it is rarely used in practice. Example, oil coolers, oil heaters and water heaters. See, parallel flow of heat exchanger. So this is a structure of it. So cold fluid is moving like this, hot fluid is moving like this. So as the two fluids are separated by a wall, this type of heat exchanger may be called parallel flow recuperator or surface heat exchanger. Counter flow heat exchanger. In a counter flow heat exchanger, the two fluids flow in opposite directions. The heat and cold fluids enter at the opposite ends. Due to counter flow gives maximum rate of heat transfer for a given surface. Hence, such heat exchangers are most favored for heating and cooling of fluids. So look at the cross flow heat exchangers. This is your mixed stream, this is your unmixed stream. So like that we are passing the two different kind of fluids like this. This is called cross flow heat exchangers. Design and constructional features of third type. On the basis of design and constructional features, the heat exchangers are classified as follows. Concentric tubes. In this type, two concentric tubes are used, each carrying one of the fluids. This direction of flow may be parallel or counter as depicted in figure. The effectiveness of heat exchanger is increased by using swirling flow, shell and tube type. In this type of heat exchanger, one of the fluids flows through the bundle of tubes enclosed by a shell. The other fluid is forced through the cell and it flows over the outside surface of the tubes. Such an arrangement is employed where reliability and heat transfer effectiveness are important. With the use of multiple tubes, heat transfer rate is amply improved due to increased surface area. Next one is multiple shell and tube passes. Multiple shell and tube passes are used for enhancing the overall heat transfer. Multiple shell pass is possible where the fluid flowing through the cell is rerouted. The shell side fluid is forced to flow back and forth across the tubes by baffles. Multiple tube pass exchangers are those which reroute the fluid through tubes in the opposite direction. Next one is compact heat exchangers. These are special purpose heat exchangers and have a very large transfer surface area per unit volume of the exchanger. They are generally employed when convective heat transfer sufficient associated with one of the fluid is much smaller than that of associated with the other fluid. Example, plate fin, flattered fin tube exchangers. So this is your structure of shell and tube heat exchangers. Final type is physical state of fluids. Depending upon the physical state of fluids, the heat exchangers are classified as follows. One is condensers. In a condenser, the condensing fluid remains at a constant temperature throughout the exchanger, while the temperature of the cold fluid gradually increases from inlet to outlet. The hot fluid loses the latent part of heat which is accepted by the cold fluid. Evaporators. In this case, the boiling fluid remains at a constant temperature while the temperature of the hot fluid gradually decreases from inlet to outlet. Thank you.